Hi, my name is Daniel Raimondo, and today I will be instructing you on the concept of graphing rational functions. The question we will be looking at today gives us two rational functions, and we will be comparing them. To do this, we will be using the function to be able to draw the graph. So let's look at the problem. Without using a graphing calculator, compare the graphs of the rational function f of x equals 3x plus 4 over x minus 1, and g of x equals x minus 1 over 2x plus 3. To solve this, we will be graphing them both individually and then comparing the differences and similarities. We will do this through finding the vertical and horizontal asymptotes of both, then finding x and y intercepts, and then plotting a few extra points through substituting the x values to find the y values. From this, we will get a good estimation of our graph and be able to draw them. So first, we will look at the first equation, which is f of x equals 3x plus 4 over x minus 1. Vertical asymptotes occur when the denominator has a factor that is also not in the numerator. In this case, in the denominator we are given x minus 1, which is not also in the numerator, so from this we can find that the vertical asymptote is x cannot equal 1. Now, for the horizontal asymptote, we first need to look at the degree of the numerator and the denominator. And the degree of the numerator is the same as the denominator, so this tells us that the horizontal asymptote will not be y equals 1, as that would be if the numerator is less than the degree of the denominator. But for our case, when they are the same, we will be using the ratio of the two leading coefficients. The leading coefficients give us 3 over 1, so the horizontal asymptote is y equals 3. So we can graph the equation, we will be finding the x and y intercepts. To find the x-intercept, we will sub in 0 for y and can figure out that the x-intercept will be negative 4 over 3. For the y-intercept, we can make x equal to 0 and find that the y-intercept is negative 4. Now we can plot these onto a graph with a dotted line to show our asymptotes. To complete this graph, we can sub in a few x values into the function to find the corresponding y values to complete our graph. I use the x coordinates of negative 4, 0.5, 2, negative 2, 3, and 6, so it can become very, very accurate. The more points that are used, the more accurate your graph will be. But plotting 3 is usually more than enough, and it depends on what your teacher is looking for. But for this, to make it very accurate, I used more than 3. From our graph, we can clearly see that where our asymptotes are and our intercepts, and we can understand how we got them. As proof, we can use Desmos just to see how accurate our graph was. Looking at this graph on Desmos, our graph was very, very accurate, and just to point out a few things, we can see that our x-intercepts and y-intercepts were correct, and that there are no x values for 1, showing that we were able to find out the vertical asymptote, and the same goes for the horizontal asymptote. Now looking at the second rational function, f of x equals x minus 1 over 2x plus 3. We can also see here, similarly to the first one, that the denominator is not common to the numerator, so there will be a vertical asymptote. We can use the denominator and find that x cannot equal negative 3 over 2. Looking at the equation, we can also see that the degree of the numerator and denominator is the same, so we can use the leading coefficient once again to find the horizontal asymptote. This gives us y equals 1 over 2, which also means 0.5. Now that we have our asymptotes, we can once again sub in 0 for x and y to find the intercepts. Through doing this, we can see that the x-intercept will be 1, and the y-intercept will be negative 1 over 3. We can now graph our intercepts and draw the dotted line where our asymptotes will be. To complete this graph, we can sub in more x values. I used negative 1, negative 2, and negative 3 to complete this graph. As you can see through Desmos, the graph we drew is very accurate compared to the one on Desmos and was done correctly. The more points we sub in, even more accurate it will be. Comparing the two graphs, they are similar and different in various ways. For both of the graphs, there is only one vertical asymptote and only one horizontal asymptote, which is not at y equals 0. This is because both of the rational functions have the same degree in the numerator and denominator. They also both do not have pinholes, and that would only occur when the degree of the numerator is greater than the degree of the denominator, which is not present in either of our functions. Both of them have one x and one y intercept. The difference is that the asymptotes are in different spots, and that is because of the value of the numbers given in the numerator and denominator, and also our intercepts are different based on the numbers we were given. To add to this, there's actually ways in which rational functions are used in real-life jobs. One example is before surgery on a patient might be injected with some medication. When the concentration of the drug in the bloodstream is at a desired level, the operation will begin. You can model the concentration of the drug in the patient's bloodstream using a rational function. A rational function can represent the concentration of a drug in the patient's bloodstream with the respect to time. Being able to determine when the drug will wear off on the patient is very important. Imagine not knowing how to do this and the patient waking up. This is just one of the many ways rational functions can be used in a real life career. Thank you for watching.